Welcome, curious minds, and welcome to TechDaily.ai for another deep dive.
Great to be here.
Today, we're plunging into a topic that might just fundamentally transform how you think about your home network. You know, those devices quietly humming away in your living room. We're going to uncover the surprising, often overlooked power lurking within a device you probably already own and use every single day. Your router.
That's absolutely right. Yeah.
Yeah.
We're talking about taking that common, unassuming piece of kit, your router, and turning it into, well, a powerful, incredibly resilient network storage server.
Wow.
Imagine empowering yourself to truly take back control of your digital life, Centralize all those scattered files and, crucially, protect your precious data against loss.
Yeah, that lost part is huge.
It is. And all without needing to invest in a dedicated, often pretty expensive server, or relying solely on cloud services. This deep dive is really designed to reveal those genuine aha moments.
That's moments. I like that.
Yeah, where existing technology suddenly unveils capabilities you just never knew it possessed.
And our mission today is pretty clear, I think. We're going to unpack the entire step-by-step process of this transformation. We'll meticulously explore the critical components you'll need, demystify the somewhat technical but incredibly powerful concept of data redundancy,
Yeah, that's key.
and reveal how it fundamentally safeguards your personal files. So get ready to see that little box in your corner in a whole new, much more powerful light.
Definitely.
So to kick things off, let's just address the fundamental question here, because it's probably on a lot of our listeners' minds. Why? Why would someone even want to turn the router into a network storage server in the first place?
Right.
What's the real problem we're trying to solve here, beyond just, a fun tech project?
That's an excellent and honestly essential place to start, because the core idea revolves around something called a network-attached storage server, or NAS for
You're
short.
right. Heard of those.
Yeah. Now, for those who aren't steeped in networking jargon, just think of a NAS as your own personal centralized digital hub, like a kind of super organized digital safe deposit box for all your files.
Okay.
And it's accessible from every device in your home. This hub lives right there on your local network, meaning it's always ready to share with your laptop, your phone, your smart TV, or, well, any other connected gadget. The reason this concept is so compelling becomes immediately clear when you consider the common digital challenges we all face in our daily lives.
Oh, I know this one personally. Scattered data, right? It's everywhere.
Mm.
My photos from last year's vacation are stuck on my old phone.
Yep.
My work documents, saved locally on my laptop. That family movie night collection, it's spread across like 3 different external hard drives and a tablet.
Exactly, yeah.
It's not just a digital mess, it's a digital scavenger hunt every single time I need something specific. Drives me nuts.
Precisely. That scattering of data across multiple devices, laptops, phones, tablets, external hard drives, even, cloud services that might not sync perfectly, it's a colossal pain point for almost everyone. A NAS, especially when you build yourself using this method, provides some really elegant solutions to these everyday frustrations. The benefits are immediate and, frankly, kind of life-changing for your digital organization.
How so?
Well, imagine the sheer ease of file sharing among family members. No more emailing massive attachments back and forth. No more fumbling with USB sticks.
Oh, the USB stick shuffle. Yeah.
Everyone in your home network can instantly access shared documents, photos, or even collaborate on projects from a single centralized location. It just works.
And for anyone who's ever experienced that sheer panic of a lost or broken phone or a crashed laptop, I mean, the idea of centralizing all those precious memories and documents must be incredibly appealing.
It is, absolutely. Think about centralizing all your precious photos, your central tax documents, your kids' school projects, those irreplaceable videos,
Right.
all in one secure location.
Right.
This creates a robust, reliable backup strategy that's far more effective than, hoping you remember to manually copy files to an external drive every so often, which, let's be honest, most of us don't do consistently.
Guilty. Yeah.
And for the media enthusiasts out there, it's a total game changer. You can store your entire collection of movies, TV shows, music on your NAS, and stream it seamlessly to any smart TV, tablet, or gaming console in your house.
Without clogging up the individual device storage.
Exactly. Without clogging individual storage or dealing with slow network transfers from, say, a laptop that has to be turned on. It transforms your home into a personal media powerhouse.
And the appeal of doing it yourself, using a router you might already have, that must be a huge draw.
Right.
Rather than buying an off-the-shelf NAS device or paying for ongoing cloud storage fees.
Definitely.
It's not just about cost effectiveness then, but also about that crucial element of control over your own data.
Right. You've hit on the essence of it.
Yeah.
The DIY solution isn't just about saving money, although that's a significant factor for sure.
Yeah.
I mean, when you consider the average cloud storage subscription, typically running, what, $10 to $15 a month for a decent amount of storage?
Easily.
Over a year, that's $120 to $180. In just a couple of years, you can easily spend more than the cost of building your own robust private system.
That's a good point.
And those dedicated pre-built NAS devices, while excellent, they can range from a few $100s for basic models to well over $1,000 for more advanced ones. And that doesn't even include the cost of the hard drives themselves.
Right, you still need the storage.
Exactly. This project empowers you to build a resilient system on your own terms, with hardware you understand and control. You're not trusting some third party with your most personal information. You are the sole custodian of your data right there in your own home.
Here's where it gets really interesting for many people, I think. Most of us, myself included sometimes, think of a router as just for Wi-Fi, right?
Yeah, pretty much.
It's that unassuming black box in the corner, maybe blinking mysteriously, that just gives us internet access. The idea that it can be repurposed for something as powerful and, frankly, sophisticated as centralized, redundant storage, that's a genuine revelation.
It really is.
It's like finding out your coffee maker can also moonlight as a surprisingly capable 3D printer or something.
Yeah. Yeah, it truly is that kind of surprising revelation. While many routers are primarily designed for network connectivity and routing internet traffic, a significant number of modern ones come equipped with a seemingly innocuous but absolutely crucial feature, a USB port.
That little port on the back, yeah.
Exactly. Most people glance at that lonely USB port on their router and might think, oh, printer only, or just ignore it altogether. But that tiny port is the key. It's the gateway to unlocking a secret superpower, transforming your humble router from a simple internet gateway into a potential personal data vault.
Wow.
It's about leveraging an existing, often entirely underutilized feature to unlock truly significant utility and control over your data. It's a testament to the versatility hidden within our everyday tech.
Okay, so if we're going to pull this off and leverage that hidden USB port, let's unpack this. Let's get into the nitty-gritty. What do you actually need, component-wise, to turn this dream into a reality? What's the essential toolkit beyond just your standard router?
Okay, the toolkit for this project is surprisingly straightforward.
Yeah.
But each piece plays a vital and interconnected role. First, and obviously you need the router itself.
Right.
As we just discussed, the absolute non-negotiable requirement here is that your router must have at least one USB port.
Must have, okay.
This port is the gateway, the physical connection point for bringing external storage into your router's ecosystem. Without it, this particular DIY project simply isn't possible. It's the starting gun for the entire transformation.
And is any USB port fine? Or are we looking for something specific to get the best performance? Because I know there are different versions of USB out there, USB 2, USB 3.
That's a critical distinction, and you're absolutely right to ask. While any USB port will technically work to connect external storage for optimal file transfer speed, and believe me, you'll want optimal speed when you're moving large files like, say, 4K videos or backing up your entire photo library, we strongly recommend a USB 3.0 port.
USB 3.0.
Got it. The difference between USB 2.0 and USB 3.0 is not just significant, it's like a night and day experience.
Really?
Yeah. Think of it like this. USB 2.0 is maybe a single-lane country road with a speed limit around 480 megabits per second, theoretically. USB 3.0, on the other hand, is like a multi-lane superhighway, capable of theoretical speeds up to 5 gigabits per second.
Whoa, that's a huge difference.
It's more than a 10-fold increase in potential speed. In practical terms, this means transferring, say, a 10-gigabyte video file could take minutes with USB 3.0 compared to potentially an hour or more with USB 2.0.
Ouch. Yeah, okay.
That directly translates to less waiting and a much snappier experience when you're interacting with your new network storage. Definitely worth looking for.
That makes a huge difference in user experience, especially with media. Okay, so router with a USB port, ideally 3.0. What's next on the list? The actual storage, I presume, the drives.
Precisely. Next, you'll need the hard drives. The source material specifies 2 traditional hard drives, and this is absolutely key for our data protection strategy.
2 drives, okay.
And here's a crucial detail that often catches people out. They must have the exact same capacity.
Same capacity, why is that?
We'll get into the why more when we talk about RAID. But essentially, for mirroring to work effectively, the drives need to match. So, for example, if you're planning on 1 TB of usable storage, you'll need 2 identical 1 TB drives.
Okay, 2 1 TB, not 1 2 TB.
Exactly. The reason we specify traditional hard drives, rather than maybe more expensive solid-state drives, SSDs, is primarily cost-effectiveness for bulk storage in a NAS context. Raw capacity is often prioritized over extreme speed here, especially given the router's own potential limitations.
Makes sense.
The primary undeniable motivation for using 2 drives of the same size, rather than just one large one, is explicitly to protect data in case one of them fails.
Ah, redundancy.
Exactly. This introduces the concept of data protection and redundancy right from the start, which is a major benefit and differentiator of this DIY setup compared to just, plugging in a single external drive.
So it's not just about adding more space, it's about making that space incredibly resilient, almost bulletproof against a single drive failure. That's genuinely clever.
Mm-hmm.
But how do these 2 hard drives connect to the router? Do you just plug them both into multiple USB ports on the router, if your router even has 2? Or?
A common misconception. You don't directly plug both drives into the router. That brings us to the third essential component, and arguably the unsung hero of this entire setup, the hard disk box, or you might hear it called an external drive enclosure.
Okay, an enclosure.
This device serves a critical dual function. Physically, it's specifically designed to house and connect those 2 traditional hard drives internally. The source explicitly shows it has dedicated connection interfaces for both HDD1 and HDD2 inside.
Right.
And then it connects as a single unit via an external interface, USB, for our purposes, to your router. But the key feature, the intelligent core that truly elevates this project, is that it must support redundancy settings, specifically RAID settings.
RAID. Okay, that word again. Yeah.
This isn't just a simple box for holding drives. It contains a dedicated RAID controller chip. This chip is the brain that manages the complex task of duplicating your data across both drives. It offloads that intensive processing from your router and ensures the crucial data protection we're aiming for.
So the enclosure does the heavy lifting for the redundancy part.
Precisely. Without this capability, your 2 hard drives wouldn't be able to work together in a way that safeguards your data in real time. It's essential.
Redundancy settings, RAID settings, that definitely sounds like where the real magic happens, or at least where the complexity lies. So the hard disk box supports something called RAID. What does that even mean in plain language, and why is it so important for protecting your data? Is it just about having a backup copy, or is there more to it?
That's precisely where we dive into the technical heart of this project.
Right.
I mean, it's a concept that truly elevates this DIY solution from simple external storage to a robust fault-tolerant system. So RAID, it stands for Redundant Array of Independent Disks. In general terms, RAID is a technology that combines multiple physical hard drives into one or more logical units. Its primary purpose is either to significantly improve performance, making data access faster than a single drive could manage, or, and this is our focus here, to provide redundancy.
Redundancy being the key for safety.
Exactly. Redundancy means protecting your data against a drive failure. It's not just about having a simple separate backup copy you make occasionally. It's about a continuous, real-time data protection system that operates at a fundamental level.
Okay, so it's not just more storage, it's smarter, more reliable storage. And the source mentioned RAID 1 specifically. What does that particular mode mirroring actually do? How does that work?
Right. RAID 1 is what's known as mirroring, and it's arguably the perfect RAID level for home users who really prioritize maximum data safety with minimal complexity. Here's how it works. The hard disk box, which you've set to RAID 1 mode, essentially only recognizes data stored on one hard drive and backs it up to another hard drive.
Okay, mirrors it.
Exactly.
Yeah.
Think of it like this. When you save a file to your new network drive, it's not just written to one disk. It's simultaneously, automatically, and identically written to both hard drives in the enclosure.
At the same time.
At the same time. It's like writing everything down twice in 2 identical notebooks every single time you make a note.
Sure.
Or imagine you have 2 security cameras recording the same scene, both writing to separate but identical video recorders at the same instant.
Ah, okay.
So at any given moment, you have an exact, real-time, bit-for-bit copy of all your data on both disks.
So the aha moment here is truly about data security, and it's a huge one. If one drive fails, just stops working, You don't lose anything because it's duplicated right there on the other one.
Precisely.
That sounds like a dream come true for anyone who's ever experienced the nightmare of data loss. I know I have.
Exactly. The primary benefit and the biggest aha moment for many is precisely that. If any hard drive fails, data will not be lost. If one drive suddenly dies, stops responding, becomes corrupted somehow, all your data is still perfectly safe and immediately accessible on the second mirrored drive.
Wow.
You can simply replace the failed drive with a new one of the same capacity, and the system, the RAID controller in the enclosure, will automatically rebuild the mirror, copying all the data from the good drive to the new one, usually without any downtime or data loss for you.
That's amazing.
It offers an incredible level of resilience and peace of mind that a single hard drive simply cannot provide. It's like digital insurance for your precious files.
That's a truly massive peace of mind. Okay, but there's a crucial implication here, right? Something the source hinted at with that example. 1,000 gigabits plus 750 gigabit equals 750 gigabits. Can you explain what that means for usable capacity? Because it sounds like you don't get the full combined storage of both drives. This is the trade-off, isn't it?
You've absolutely hit on the critical trade-off with RAID 1, and it's important to understand this up front. Because your data is being duplicated or mirrored across both drives, your usable storage capacity is effectively limited to the size of a single drive.
Okay, only one drive's worth.
Right. So if you install two 1 terabyte TBs, you don't magically get 2 TB of storage, you get 1 TB of usable storage. The other 1 TB is basically serving as the real-time continuous backup copy.
Okay.
And as that example, 1,000 gigabit plus 750 gigabit equals 750 gigabits, vividly illustrates, if your two drives happen to be different capacities, say you put in a 1 TB drive and a 750 gigabit drive, your usable storage will always be capped by the smaller drive.
Always the smaller one.
Always. In that specific example, it would be 750 Garolini. The larger drive will only be used up to the capacity of the smaller one to mirror its contents, essentially wasting any extra space beyond that.
Gotcha.
So yes, it's the cost of that robust, real-time data safety. You sacrifice half your raw storage potential for guaranteed immediate redundancy. It's a choice to maximize safety over raw capacity.
So it's a strategic decision to prioritize data integrity. Makes sense. And how do you tell this hard disk box to actually do RAID 1? Is there a button or a specific switch setting on the enclosure itself? How does it know?
Yes, it's usually a physical setting on the hard disk box itself, and this step is absolutely crucial. The source emphasizes the importance of following the enclosure's instructions carefully for setting it up, as specific models might have slightly different layouts or methods.
Right, check the manual.
Definitely check the manual. However, for RAID 1, it generally involves setting physical switches or dials on the enclosure itself. Specifically, the source material mentions you need to set switch 1 to number and switch 2 to on.
Physical switches. Okay.
These are physical switches or maybe jumpers on the enclosure that tell its internal RAID controller which mode to operate in. For our purposes, setting them precisely as instructed enables RAID 1 mirroring, ensuring your data is always duplicated from the moment you start using it.
And you do this before putting the drives in?
Yes, that's the key. This is a critical step that must be done before you even install the drives or connect it to your computer, as it dictates how the box will recognize and manage the drive moving forward. Get the mode set first.
Okay. Now that we know why RAID 1 is so important for data protection and how to set that mode on the hard disk enclosure, let's get hands-on. Let's talk assembly. What's the very first physical step in getting these hard drives ready and installed into their new home?
All right, with your hard disk box physically configured for RAID 1, the first practical step is installing the drives into the box. This is a fairly straightforward mechanical process, but it does require a bit of care. You'll need to align the hard disk with the installation port to install and secure the hard disk.
Line it up carefully?
Exactly. The source explicitly shows this for both hard disk 1 and hard disk 2. Most enclosures have specific bays or trays that the drives slide into. Once aligned and properly seated, you then secure it with screws using divided hardware.
Don't want them rattling around?
Definitely not. It's essential to make sure they are firmly seated and won't wobble. This ensures a stable connection for continuous data transfer and minimizes any physical stress on the drives. Repeat this process for both drives. Secure them both.
So screw both drives in securely. Is there anything else with the physical box itself once the drives are in their individual slots? Putting the lid back on, sorta?
Yes, exactly. Once both individual hard drives are secured within their respective internal slots inside the enclosure, you then insert the installed hard disk module into the external hard disk box and secure it with screws. This is the final step of the physical assembly. where the internal drive cage or module is sealed within the external casing. It transforms it into a single, self-contained, robust unit ready for connection, like putting the engine and transmission into the car chassis, as the source sort of implied.
Got it. Boxed up and ready. Okay, so the drives are in the box. The box is sealed and configured for RAID 1. Now, this next step seems a bit counterintuitive, maybe, because you don't just plug it into the router yet. You need to connect it to a computer first, right? Why is that initial computer connection absolutely necessary?
That's a crucial insight, and it's because, quite simply, the router cannot format the hard drives.
Ah, okay. That makes sense.
Your router, even a powerful one with USB ports, is optimized for network traffic, right? Not for low-level disk management or creating file systems. Routers typically lack the sophisticated disk management capabilities and operating system-level tools that a full computer provides. So before your router can recognize and use the storage for your files, it needs to be properly initialized and formatted. That's why you connect the hard disk box to a computer via USB using the provided USB cable.
And power it on.
Yes. Good catch. Don't forget the small but important step. Don't forget to press the power button on the hard disk box itself to turn it on. Otherwise, your computer won't detect it at all.
Right. So how do you actually format it on the computer once it's connected and powered up? What specific steps do you take to prepare it? Walk us through that.
Okay. Once connected and powered on, you'll need to open your computer's disk management utility. On a Windows machine, you typically find this by typing Disk Management into the Start menu search bar, or sometimes right-clicking on this PC and selecting Manage, then Disk Management.
Okay, disk management.
When you open it, you should see a new disk detected, often labeled as Disk 1 or something similar, probably showing as unallocated space. Now, here's another truly fascinating aha moment, directly resulting from the RAID 1 setup we configured earlier.
What's that?
Although there are two hard disks physically inside that enclosure, the computer only detects one hard disk.
Whoa, really? Just one?
Just one logical disk. This is because, as we discussed, the hard disk box uses RAID 1. Its internal controller takes those two physical drives and cleverly presents them to your computer's operating system as a single, unified logical volume. Your computer doesn't see two separate disks. It sees one incredibly reliable storage unit. It's a testament to how seamlessly RAID works in the background, abstracting the complexity of multiple drives into one manageable unit for the OS.
That's genuinely fascinating. It really makes it seem like a single, larger, more robust drive to the computer.
Okay.
And then you just format that one logical drive as you would any new storage. What kind of format should you use? Any recommendations?
Exactly. You then proceed to format this single detected logical hard disk. The source shows the process, including giving the volume a descriptive label like NAS, which is a very practical and recognizable name for a network storage drive.
Good idea, yeah. NAS.
As for the file system, for a network-attached storage like this, a common and highly recommended format for maximum compatibility and support for large files is either XFAT or NTFS.
Okay, XFAT or NTFS.
Yeah, NTFS is great primarily for Windows environments, but XFAT often offers better cross-platform compatibility if you think you might want to access the NAS from macOS or maybe Linux machines down the line. Plus, it also handles very large files well, better than older formats like FAT32.
So XFAT might be safer for mixed environments.
It often is, yeah. Once formatted, it will show up as a ready-to-use partition in your computer's file explorer. The source explicitly states this is the partition after being formatted, confirming it's prepared and ready for data. This formatting process prepares the drive with the file system that the router can understand and use for storing your data.
And the final crucial step before moving on, after formatting it on the computer, it's often overlooked, but so important, right? Safety first.
That's right. The crucial final step is to safely disconnect the hard disk box from the computer. Just like you would with any external drive or USB stick, you should use the Safely Remove Hardware option, or its equivalent on your operating system, like ejecting a drive on macOS.
Don't just yank the cable.
Please don't just yank the cable.
Oh.
Forcefully unplugging a drive, while it might still be accessed, even in the background, can lead to data corruption, file system errors, or, worst case, even physical damage to the drive sometimes.
Okay.
Once it's safely disconnected and you've confirmed it's okay to remove, it's truly ready to meet its new home, your router.
All right, so you've got your hard drives installed and formatted, all configured for RAID 1 inside that special enclosure. Now, for the moment of truth. How do we actually connect this physical unit to the router and make it a functional network server? This is where all the pieces finally come together, right? The big connection.
This is indeed where the entire project culminates, and it's surprisingly simple on the physical side. You simply connect the hard disk box to the router using a standard USB cable. Plug it directly into that router's USB port we identified earlier, ideally the USB 3.0 port if you have one.
Plug it in.
Plug it in. Once that physical connection is made and the hard disk box is powered on, the real work begins on the network side, configuring the router to recognize and share this new storage.
And how do we tell the router that it suddenly has this new, powerful storage attached? Do you just wait for it to magically appear, or is there a specific setup process within the router's interface? Where do you look?
Not quite magical, unfortunately. You need to explicitly tell the router to look for and manage this new storage. You'll do this by accessing your router's administrative settings page.
Log into the router.
Exactly. From any computer on your local network, the same network your router is broadcasting, you'll open a web browser and enter the router's IP address. This is typically something like 192.168.0.1 or maybe 192.168.1.1. It can vary by router brand.
Check the sticker on bottom usually.
Yeah, check the sticker or the manual if you're unsure. Once you're logged into the router's interface, you'll likely need the admin username and password, which hopefully you've already changed from the default for security.
Hopefully.
You'll navigate through its menu. The source indicates a common path. Look for a section named Advanced, then usually something like USB or USB settings, and finally, USB storage device. Or maybe just storage.
Okay, advanced USB storage, something like that.
Exactly. This section is specifically designed for managing external storage connected to the router.
And what if the router doesn't immediately see the hard disk even after I navigate to that section? Is there a common troubleshooting step for that? Sometimes things don't show up right away.
That's a very practical question, as it can definitely happen. Sometimes it takes a moment for the router to recognize newly connected hardware, or perhaps there was just a minor hiccup in detection. The source advises a simple but effective step. Click Refresh if the router does not detect the hard disks.
Ah, the refresh button. Classic.
Usually does the trick. This prompts the router to rescan its USB ports and reevaluate connected devices. If everything is set up correctly, meaning the hard disk box is powered on, securely connected via USB, and the drives are properly formatted, the router should then detect and list the single logical hard disk that was prepared on the computer.
So it should show up as one drive again, like on the computer.
Exactly. This confirmation, seeing it listed in your router settings, is your definitive green light. The storage is now online and ready for network sharing. If it still doesn't appear after a refresh, you might try power cycling both the hard disk box and the router, maybe wait 30 seconds, power them back on, or just double check all the physical connections again.
All right, your router has detected the storage, it's online, the green light is metaphorically flashing. Now, this is the moment we've been building towards. How do we actually access this newfound network server from our other devices, our laptops or phones? And perhaps even more importantly, how do we make absolutely sure it's secure so not just anyone who hops onto our Wi-Fi can snoop through our private files?
Excellent points. Both access and security are paramount, and they often go hand in hand, really. Now, by default, with many routers, once external storage is detected and ready, the router has shared enabled on the local network.
Enabled by default, okay.
Yeah. This means, theoretically, if you know the router's IP address and maybe the default shared solder name, you could potentially try to access it. The direct address to access it will typically be the IP address of the router, for example, 192.168.0.1 on Windows.
But just because it's enabled by default doesn't mean it's truly secure, does it? That sounds like a potential vulnerability if someone else gets onto my Wi-Fi network, like a guest or worse.
Precisely. You're absolutely right. While convenient for a quick setup, default sharing often lacks proper access controls and is a significant security risk. This is why the source makes a very strong, almost urgent recommendation. I recommend you to share securely.
Share securely. Okay.
This isn't just a suggestion. It's a critical security measure to protect your private data. To do this, you'll go back into your router's USB storage or file sharing settings area. You'll typically find an option somewhere in there to enable secure sharing, and maybe set something like Shared Account Share Default. This moves you from an open, anonymous share to one that requires authentication, a username and password.
Authentication. Good. And the single most crucial security measure, the one thing everyone should absolutely do without fail, I'm guessing it involves passwords and definitely not the default ones.
You've nailed it. And I cannot overstate the importance of this step. Changing the default password Seriously. The source provides an example of a weak, easily guessable default password like 12345A.
Yeah, terrible password.
Awful. Default passwords are often publicly known or easily cracked through simple brute force attacks or dictionary attacks. Leaving your NAS protected by a default password is like leaving your front door wide open with a giant welcome mat outside. It's an open invitation for anyone on your network, whether an unexpected guest or a determined hacker, to snoop through or even delete your most personal files. You must change it to a strong, unique, and complex password.
What counts as strong?
Good question. Use a combination of uppercase and lowercase letters, numbers, and special characters like exclamation points or hash symbols. Aim for a password that's at least 12, 16 characters long, ideally longer. Consider using a password manager to generate and store it securely, because remembering something that complex is hard.
Good tip. Password manager.
This creates a robust, secure barrier, ensuring that only authorized users, meaning you and anyone you explicitly grant access to, can log in and access your files on the network. Once you've set that new, strong password, be absolutely sure to find the Save or Apply button in your router settings. Make sure it sticks.
Right. Save the changes. Okay, so secure sharing enabled and a strong new custom password set. Now, the moment of truth for accessing it. How do I actually get to the files from my computer or other devices on my local network? What's the procedure?
Okay, to access the shared folder on your local network, from a Windows computer, for instance, you'll use the Run window. A quick way to open this is by pressing the Windows key plus R on your keyboard.
Win plus R.
Got it. In the Run dialog box that pops up, you'll enter the IP address of your router, but it needs to be prefixed by 2 backslashes. So it would look like this: 192.168.0.1, replacing that IP with your actual router's IP, of course.
Backslash IP address. Okay.
When you hit Enter, a login prompt should appear. Here, you'll use the username admin, which is typically the default username for router access, though some routers might let you customize this as well, and crucially, the strong custom password you just set for secure sharing.
The new password, not the router login password necessarily.
Right, the password you set specifically for the secure share. If everything is configured correctly, you should get an OK successful confirmation or something similar, and a window will open showing your shared network drive. You can now browse, upload, download files. Success.
That's pretty straightforward for initial access. And good to know the login uses that secure share password. But for everyday use, repeatedly opening the Run window and typing in an IP address, that might get a bit tedious, right?
Yeah.
Is there a more convenient way to make this network storage feel like it's just another drive integrated seamlessly into your computer?
There absolutely is, and it significantly enhances convenience, making your network storage truly feel like a native part of your computer. You can map network drive.
Map network drive. Okay.
This makes your network storage appear as a regular drive letter, like maybe Z or Y, directly under this PC or my computer in your file explorer, just like your C drive.
Oh, that's much better. How do you do that?
The process usually involves right-clicking on this PC or sometimes network in your file explorer, selecting Map Network Drive. In the window that appears, you'll enter the router's IP address again with the backslashes, like 192.168.20.1 as the network path or folder. Choose a drive letter that's not already in use, make sure Reconnected Sign-In is checked if you want it to be persistent, and click Finish.
Okay.
Then you can even rename it for easy remembering, maybe calling it My Home NAS, Family Files, or Router Storage, whatever makes sense to you. This way, accessing your centralized data is as simple as double-clicking any other drive on your computer. Super convenient.
That's brilliant. Yeah, that really integrates it into your daily workflow, making it feel less like a remote server and more like local storage.
Awesome. And once it's mapped,
Yeah.
how do you confirm it all works as expected? Just try using it.
Exactly. The best and simplest way to confirm is to simply test it. As the source shows, you can just upload any file to this new network drive. Drag and drop a document or a photo onto the mapped drive letter.
See if it copies over.
Right. If the file transfers successfully to the mapped drive, you know your new network storage server is fully functional and ready for use. This is also where the impact of your router's USB port type becomes immediately apparent again.
Ah, the speed thing. Yeah. If you opted for a router with only a USB 2.0 port, the source mentions USB 2.0, so the speed is not as expected. You might notice that transfers, especially for larger files, feel a bit sluggish, maybe even frustratingly slow.
Yeah.
This just reinforces our earlier recommendation to really try and use a router with USB 3.0 if possible. You'll get much faster transfer speeds and a much more responsive experience when dealing with larger files or frequent transfers. It's the difference between a brisk walk and a leisurely stroll for your data.
So USB 3.0 is definitely the way to go for a snappier, less frustrating experience if you can manage it.
Yeah.
Okay. Now, this entire setup has focused on accessing files from within your home network, right? Local access. But is this setup just for local use, or is there potential to access these files from outside your home, say when you're traveling or at work?
That's an excellent follow-up question, as the ability to access your files from anywhere is incredibly liberating and a major benefit of many NAS solutions. Now, while this specific deep dive has focused on setting up your network storage for local access within your home, the source does briefly mention that also you can access the shared folder from the internet.
Ah, okay. So it is possible.
It is possible. It's an important acknowledgement of its broader capabilities.
Mm.
However, and this is a big however, it's absolutely crucial to understand that setting up secure remote access requires additional, often more complex steps. And importantly, it introduces significant new security considerations.
Right. Opening it up to the internet is risky.
It can be if not done properly. This often involves concepts like dynamic DNS services, or DDNS, which help your router maintain a consistent address on the internet, even if your home IP address changes, which it often does.
Okay.
It also involves configuring port forwarding on your router, which literally opens up specific pathways from the internet directly to your NAS service running on the router. You have to be very careful with that.
Sounds complicated.
It can be. And potentially, for better security, setting up a virtual private network or VPN server on your router itself might be the best approach. That creates an encrypted and much more secure tunnel connection back to your home network before you access the files.
A VPN on the router. Okay.
So while the potential is certainly there to turn your router into a truly global data hub, these steps require careful configuration and a thorough understanding of the security implications. It's really an entire deep dive in itself, but it's powerful to know that the foundation you've built can potentially be extended for anywhere, anytime access if you're willing to tackle that next level of complexity and security.
Wow. Okay. What a journey we've taken. From identifying the right router and understanding the necessary hardware, the enclosure, the two identical drives, to decoding and configuring the magic, really, of RAID 1 data redundancy for that safety net.
Yeah, the mirroring.
Then meticulously formatting those drives via computer first, and finally setting up secure network access right through the router settings. We've effectively taken a standard home router and transformed it into something much more, a robust, redundant, and highly capable network storage server.
That's absolutely right. The core achievement here is creating a system that not only centralizes all your scattered files, making them easily accessible from any device in your home, which is great, but more importantly, provides genuine, real-time data protection against drive failure. That RAID 1 mirror is key. It's a powerful, highly cost-effective, and I think deeply empowering way to take ultimate control of your digital life and safeguard your most precious digital assets.
Yeah, empowering is a good word for it.
And if we connect this to the bigger picture, our increasingly digital world, this project isn't just about saving files. It's about fundamentally understanding how your personal digital infrastructure works and taking proactive, informed steps for true digital resilience, knowing where your data is and that it's safe.
So, what does all of this mean for you, our listener? This deep dive into turning your router into a personal NAS isn't just a technical exercise in repurposing hardware, though it's cool tech.
It is cool tech.
It is. But it's also a profound invitation to consider the newfound control and, honestly, the peace of mind you can exert over your own digital assets. No longer are you necessarily beholden to scattered files across countless devices or relying on those intermittent manual backups you forget to do, or entirely dependent on potentially expensive or maybe privacy-compromising cloud solutions. You now have the knowledge and the roadmap to build your own secure, private digital vault right there in your home using potentially hardware you already own.
And this raises an important question, I think, for everyone listening. In an age of increasing data reliance, where your photos, your irreplaceable documents, your most cherished memories are almost entirely digital, how much value do you place on understanding and actively managing your own data's physical location, its accessibility, and its long-term security?
That's a deep question.
It is. And beyond just routers, maybe think. What other everyday devices, that smart home hub you rarely think about, or perhaps that old laptop gathering dust in the closet, might you be able to repurpose? With a little ingenuity and the right knowledge, could they serve a new, powerful function that you never even considered? The possibilities for leveraging existing tech often extend far beyond their initial design, just waiting for deep dive like this one to uncover them. Food for thought.